Hey guys, welcome back to my YouTube channel, and today I'm up with the next question of top 150 interview questions of LeetCode. So let's get started with the same today. And as you can see, if you have saw my previous video, this question is just an extension. I think you can solve it easily as well. But still, let's discuss the question, discuss its approach, and figure out the time complexity and space complexity of the same, and then figure out the code for the same. So let's get started. So we are given a two sum part 2 where the input array is sorted. So we are given an array of integers numbers which is already sorted in non-decreasing order, that's an ascending order. We have to find two numbers such that they add up to a specific target number, and let these two numbers weigh at numbers of index of 1 and numbers of index of 2, where index of 1 is less than index of 2, and it occurs in the range of 1 to numbers of length. So we have to return the indices of two numbers, index 1 and index 2, added by 1. It means whatever the answer of index 1 is, it's actually plus 1 of whatever the array index that we have. That's the intuition of this question. Intuition of the statement is as an integer array of length 2. So it means we have to return the array of those integers of indices which sum up to the target that we are given. And the test cases are generated such that there exists only one solution. So it means the solution is always unique. So, and you may not use the same element twice. It means that we cannot repeat the element. So suppose if I have my target as 4 and I repeat 2 and 2, that's not the ideal case for it. So, and the another follow-up is that you must only use constant extra space. It means we have to implement this question in of1 space. So before moving on to this follow-up, so let's discuss the approach for this question. So we are given an integer array and 2, 7, 11, and 15, and we are given a sum target of 9. So how we can find it out? So simple, we have to find two integers. So what we can do, we can use two for loops, one running from 1 to n minus 1, and another running from j to I plus 1 to n minus to n, and we'll simply say that if my I nums of I plus nums of j is equal to target, we'll simply add these. So if I take an answer, I'll add it to my answer I plus 1 and j plus 1, and then I'll simply return. That's the intuition of this algorithm states. So talking about the time complexity. So time complexity of this solution turns out to be of n square, and the space complexity turns out to be of 1 of n square. Why so? Because we are using two for loops, and space complexity is of 1 because this answer vector was actually a part of our what do we say, a part of a problem. So I'm not considering it as part of my space complexity because we are not exactly storing these results anywhere else. Rather, we are simply inserting these results into our answer array that we have to actually return. So, but now let's discuss the follow-up question for the same. So let's redraw this array again. I have my nums. So if you have gone through the last video, which is the threesome question, where I've discussed the two-sum approach, so what do you think? Is it something sounding similar like that? Oh yes, it is actually. So what we can do, we can simply implement over here because our array is already sorted and we have to achieve a sum, something to target. So in the two sum also, what we were actually trying to achieve, we were actually trying to achieve two numbers, like a pair of numbers which are actually summing up to 0. So in this case, rather than 0, what we are having is something like k, which is our target 9. So which is something target. So what we can actually do, we can simply implement a two pointer approach in this question, and this is the optimized solution wherein our time complexity cuts down to O of n and space complexity cuts down to O of 1. So now let's implement this solution and discuss it further. So I have, suppose, two integers I and j initialized to 0 and n minus 1. So I'll simply traverse while my I is less than j. If if now let's store this in some sum. So my sum is equal to nums of I plus nums of j. And if my sum is equal to the target, so what I will simply do, I'll simply add my uh, indices and then I'll simply return my answer and I'll simply return. That's this. And if my sum, now this is the else if part of the same. So else if my sum is greater than the target. So what I will do. So suppose now let's just discuss the two pointer for the same right now. So I have my pointer 2 and 15. My I and j over here. So what is the sum of 2 and 15? It's 17. And my target is 9. Is 17 greater than 9? So my answer is yes, 17 is greater than 9. So what we have to do in order to reach our target, we can simply we have to simply exclude 15 from our answer and move a step backward. That's the intuition. So what we'll do, we'll simply decrement our j. So now let's discuss the other case as well. If my sum is less than target, so if it's less than target, what would what would be the either case? It would have been I have to I have to ignore all the elements smaller, like I have to ignore the element which is smaller, which is contributing a smaller amount to my target, and I'll simply move in the forward direction. That's the intuition of this algorithm on the whole. So while moving up in this algorithm, we are actually traversing the whole array at most once. That's that's why the time complexity is bigger of n and space complexity is bigger of 1, because we aren't storing all of these values anywhere else. So now just continue. Now let's just finish up this dry run. So now let's calculate the sum for 2 and 11. It turns out to be 13. Is my 13 greater than 9? Yes, it is. So I'll simply decrement my j. So now let's add 2 and 7. So 2 plus 7 is equal to 9. 9 equal 9. So I'll simply add both of these indices and return. That's the intuition. That's the answer. So now let's discuss the code for the same. Let's go through the code once. So I have initialized my vector, which is my answer, to -1 and -1, and I have my numbers. I've calculated the size. I've I've initialized my I to 0 and j to n minus 1. Calculating the sum of these numbers, if it's equal to target, I'm setting these values to I plus 1 and j plus 1, and I'm simply breaking, whereas in the algorithm which I've discussed before, I'm just simply adding them to my vector and just returning it. And that could also be done, but I prefer using the break thing. That's why. So if my sum is less than target, so I'm just ignoring the values which are adding lesser to my sum. So I'm simply incrementing it, or else if my sum is greater than my target, I have to neglect all the larger values. So I am decrementing my j. So now let's run this code. Pretty simple, pretty easy. It's running fine. Let's submit it. It's done. So I hope guys you've liked the way in which I've explained the question. If you have understood this question, please do hit the like and subscribe button. If you are new to the channel, that's the one. The subscribe is for them. And if you feel that I've done really well in explaining this question, please do share it with your friends so that it gives me a support, it gives me a motivation in order to make more videos like these and come up with more good solutions to the problems of LeetCode. So thanks guys, keep watching my videos and keep supporting me. Thank you. Thanks a lot.